This is a tutorial for Lewis structures. So I began by putting together some steps and just things to keep in mind for when doing Lewis structures. So number one, very important, think about the total valence electrons. So at the end you can calculate to make sure you breach that. Number two, the charge. Is it positive, negative? Is it neutral? 3, symbols. So now think about the individual symbols of the atoms, which will connect to which. Then start thinking, can just begin and have just a single bond. Then think about, are there octets around all atoms that circle the central atom? Are there extra electrons that need to be added to the central atom? Is the central atom a octet? If it's not, then you need to add multiple bonds. Then, is this an exception? Is it an exception ion? So, is there an odd number of electrons, less than an octet? Is there more than an octet? So these are just some things to keep in mind. They're the main tips that I keep in mind when I do it. So now let's go to some examples. So the first one is going to be an exception. CH4, methane. So first let's think about what are the total valence electrons. We know for C, carbon, that it has 4. We know that H, hydrogen, has 1, and there is 4 atoms, so it's a total of 4 as well, so a total altogether 8. So we also see that this is a neutral charged ion, so there will be no extra charge. So we'll begin with the symbols C, carbon, H, hydrogen, on those. Now we will go ahead and see, can we do just a single bond between each? We know that carbon had 4 valence electrons, so 1, 2, 3, 4. Hydrogen had 1 with each, so they will all bond with just a single bond to give the octet. Carbon now has 8. 1, 2, 3, 4, 5, 6, 7, 8. Hydrogen has 2, which fills up its outer shell. 1, 2, 1, 2, 1, 2, 1, 2. So this is a Lewis structure for CH4. Now we will move to CO2, which is not an exception. It is a neutral charge. We will begin again with the valence electrons. C once again has 4 valence electrons. O has 6 valence electrons, and there are 2, so that will give you 12. And then 4 and 12 is 16. So we will begin getting the symbols again. Now we'll begin by seeing, can we just do a simple single bond? We do know that since oxygens, the 2 oxygens will have, it had 6 valence electrons. So we can go ahead and put in the pairs. That's what I always do, because I know that those will be there. And it still has 2 lone pairing ones. So can we do just a single bond to get an octet? No, because carbon only has 4. So if we do a single bond, it would only give us, carbon would only get 4, oxygen would only have 6, plus its 1 lone one. So we would take away this lone one on both, and we will double bond. So these are gone. Now, also with carbon, these will come around to bond. So you have 1, 2, 3, 4, 5, 6, 7, 8. So carbon has its octet. Now what about the oxygens? 1, 2, 3, 4, 5, 6, 7, 8. That oxygen is good. 1, 2, 3, 4, 5, 6, 7, 8. It's good as well. So this was an example of a multiple bond Lewis structure. So let's do one more example. SCN minus 1. So this one has a different charge, as we see, with a negative. So it has one extra electron. So we will first begin thinking the valence electrons. S sulfur has 6. C carbon has 4, as we've seen. And then N nitrogen has 5, which gives us a total of 15. But we have to remember there is an extra electron, so that is going to give us a total of 16 valence electrons. So we are going to go ahead and start writing this one. So we know carbon has 4. Nitrogen is 5. Then we also know that S sulfur 6. So go ahead and then so if we do just a single bond, is this going to work? We see no, that it's not, because none of the atoms are going to have their octet. So we'll go ahead and do a double bond between each. So like these little ones I had written there will go away. We'll move over here to do the double bond. So now we need to see, do all of these have the octet? Well, we see sulfur, so 1, 2, 3, 4, 5, 6, 7, 8. So it is good. Carbon, we have 1, 2, 3, 4, 5, 6, 7, 8. It is good. Nitrogen, 1, 2, 3, 4. Oh, sorry about that. This one, these two I was supposed to leave. So 1, 2, 3, 4, 5, 6, 7, 8. So now let's see. Who was supposed to hold the negative? Who gained an electron? So for sulfur, its valence electrons assigned to it are 1, 2, 3, 4, 5, 6. Sulfur, it had 6, so it is good. Carbon, it only had 4, so let's see what is assigned to it. 1, 2, 3, 4. It's good. Nitrogen, it had 5 assigned to it, but it now originally had 5 assigned to it. Right now it has 1, 2, 3, 4, 5, 6. So nitrogen is gaining our negative charge. So this will be the Lewis structure for SCN minus 1. So that's it.